In this example, I need to use the discriminant to determine the number and type of solutions of the following quadratic equations. And here I have 4 quadratic equations. So quickly reviewing, when solving a quadratic equation by factoring or using the quadratic formula, I need the equation written in standard form. That means everything on one side written in descending order, 0 on the other. And hopefully you remember the quadratic formula here. And the quantity sitting underneath the square root, b squared minus 4ac, is called the discriminant, because its value determines the number and types of solutions you will obtain for your equation. So if b squared minus 4ac is positive and a perfect square, you get 2 distinct real rational solutions, because when you take the square root of a positive perfect square, you're going to get a real rational answer. Now, if the discriminant is positive but not a perfect square, you get 2 distinct real irrational solutions, because when you take the square root of a positive non-perfect square, you're going to get real irrational answers. Now, when the discriminant is 0, you get 1 real rational solution. This is often called a repeated solution, because when you take the square root of 0, the square root of 0 is 0, so you just get left with negative b divided by 2a. And finally, when the discriminant is negative, you get 2 distinct complex solutions that are conjugates of each other, because when you take the square root of a negative number, you get an imaginary answer. Now looking at our examples, in part A, we have 3x squared minus 7x plus 5 equals 0. This is written in descending order, so I'm ready to find the values of a, b, and c. So a is the coefficient of the x squared term is 3, b is the coefficient of the x term, it's negative 7, c is the constant term of 5. So the discriminant of b squared minus 4ac is just b squared, so it's negative 7 all squared. You must put the negative 7 in parentheses, minus 4 times a is 3 times c is 5. So I get negative 7 all squared. Well, negative 7 times negative 7 is positive 49. Minus 4 times 3 is 12. 12 times 5 is 60. 49 minus 60 is negative 11. So now I know that my discriminant is negative. So I'm going to have 2 distinct complex solutions. So that is the answer to part A. Now looking at our next example, I have 2x squared equals 3x plus 6. This example is not written in standard form, so I'm going to have to subtract 3x from both sides. And I'm also going to have to subtract 6 from both sides. So on the left-hand side, 3 unlike terms, write them in descending order. 2x squared minus 3x minus 6 equals 3x minus 3x is 0, 6 minus 6 is 0. So now my equation is written in standard form. A, the coefficient of the x squared, is 2. B, the coefficient of the x term, is negative 3. C, the constant term, is negative 6. So the discriminant b squared minus 4ac is b squared, so it's negative 3 all squared minus 4 times a is 2 times c is negative 6. So I'm going to get negative 3 all squared. Well, negative 3 times negative 3 is positive 9. Negative 4 times 2 is negative 8. Negative 8 times negative 6 is positive 48. So 9 plus 48 is 57. So the discriminant is positive, but it is not a perfect square. So I get two distinct real irrational solutions. So that is the answer to part B. Now in part C, my equation is x squared plus 9x plus 14 equals 0. It's written in standard form. So A is the coefficient of the x squared. What number are we too efficient to write in front of that x squared? A 1. B, the coefficient of the x term is 9. C, the constant term is 14. So in this case, b squared minus 4ac, b is 9, so it's 9 squared minus 4 times a is 1 times c is 14. So I'm going to get 9 squared, 9 times 9 is 81, minus 4 times 1 is 4, times 14 is 56. And 81 minus 56 is 25. So in this case, the discriminant is positive, but it is a perfect square because 25 is 5 squared. So I will get two distinct real rational solutions in this case. And finally, looking at my last example of 20x equals 25x squared plus 4, it's not written in standard form. I need 0 on one side, so I'm going to subtract 20x from both sides. And I get 20x minus 20x is 0 equals 3 unlike terms on the right-hand side, writing them in descending order, I get 25x squared minus 20x plus 4. Now, is this written in standard form? Yes, it doesn't matter if all my terms are on the right-hand side in descending order and 0 on the left or the other way around. So now I have my equation in standard form. A, the coefficient of the x squared term is 25. B, the coefficient of the x term is negative 20. C, the constant term is 4. So b squared minus 4ac is b is negative 20, so it's negative 20 all squared, minus 4 times a times c. A is 25 and c is 4. So negative 20 all squared is positive 400, because negative 20 times negative 20 is positive 400, minus 4 times 25 is 100, 100 times 4 is 400, 400 minus 400 is 0. So in this case, the discriminant is 0, so I have one real rational solution that is a repeated solution. So that is the answer to part D.